Okay, I think we can start now. Hello again. Thanks for joining us today. Today, I will tell you about our framework, but before, it is necessary to discuss the problem which we are trying to deal with it. Let's discuss an upcoming industry challenge. We have two traditional roles. First role, software testing engineer, which have necessary business understanding to provide valid scenarios, but they are unable to develop auto tests. Second role is software testing automation engineer, responsible for auto test development and execution, but they have much less expertise in business. It is a lot of time and effort to provide all requirements and important details between these two roles. So to avoid such inefficiency, we need a new role to combine business understanding and ability to develop auto tests. Epam and industry overall have a great demand of this upcoming role, now when automation is a common approach. Epam calls this role software quality engineer. New role is something between two traditional ones. He is an owner of a test model. He could use automation tools to create tests, but not a developer. Also, he is able to create more or less complex SQL queries, check logs for errors, etc. as a software testing engineer. And now we can suggest an option to Epam to obtain and easy train such specialists. This option is our AWN framework, which is a tool for software testing engineer to create and execute automation tests, and like becoming software quality engineer by doing that. A few facts about AWN framework. It is one of Epam's accelerators, but it already have about 10 years history. It was successfully used on a dozen of large-scale automation projects. Approaches of our framework are evolutionarily tested and prove their efficiency. For example, it was used to test more than 2,000 test cases in a single system release. I'm going to show you how testers with no coding skills can develop complex automation tests very fast using our framework. What AWN can suggest to your team or to business? In one phrase, it's fast, complex automation with no coding skills. To have the right idea about our framework, you need to understand what is action-based testing means. This method is evolution of the keyword-based testing approach. Actions like tasks that are executed during a test. We are not automating an entire test as one long script, but test is assembled using individual actions as blocks. Non-technical test engineers can then define their tests as these automated actions. And the framework take care about execution and reporting. My colleague Konstantin will show during like demo later. Now one important thing. Right now I need 10 minutes of your attention because it will be 5 slides with concentrated content. To get the maximum from today's meeting, you need to understand the following information. So let's imagine a typical complex system. The simplest test is when we send in some request and get some response. But what is it if response is other than expected? How we can tell what component is broken or out of place? Testing is not about to send a request and wait for a valid response. The real test will tell you where is the error if response was not as expected. Front-end itself, it's like just part of a big system. Itself is a complex system. It have entry point, some logic and adapter for downstream components. We need to check log for our request on each of them. Also, we need to check application config for some important strings. Next subsystem is like messaging layer, which have hundreds of queues, message brokers, etc. And we need also to check here. And backend system have own adapter logic, some configurations, and database. One message can produce multiple SQL requests and so on. We need to check everything here to make sure that it's working. And we need to check response for each request, for each message, also on the front end. So somewhere here we found an error, and it's only for one system. Usually there are a lot of them using message and bus to reach backend logic, and we need to test them all. And in end-to-end testing, many places to broke something. We should collect all available information to have an idea where the problem is. But if we have an expected response, these steps can be omitted. And all this story becomes manageable if you have a single auto test which checks and validates every step and reports the problem, if any, especially if you don't need coding skills for that. How is it possible? Each test is assembled from different steps. Each step contains action of certain type, like open file, extract value from XML, fill form, and so on. We have a lot of predefined actions out of box. Next is action parameters, like function parameters. For example, file location, XPath, input data, and some checks and validations to decide if action was successful or not. For example, here in step 2, we're using action to run another test as a subtest. It's cool mechanism, and because this subtest can be developed by some other person for some subsystem component. For example, it can be test which creates a new credit card in the database and contains near 30 internal steps. After this subtest is finished, I have a brand new just created credit card number and other card data, which I can use later in other subtest, which makes the payment using such card, for example. So any test case on the whole project where I need a card for any reason to block it, to pay with it, receive some money, etc., I can just reuse such test every time. The data produced by it can be used later in the same test or within the test suite if you need. By exporting and importing variables, write some variable to a suite or test context. The next test can read this variable. But single create card test can have different input parameters to create a specific card type. Here we have one test which covers 81 different use cases to reuse everywhere you can possibly need them. You can pay for your ice cream using any desirable card type. So using such approach, you can expand your test model fast by reusing these chunks of functionality. For complex system, we can't have one person to develop all tests. Usually, different experts dealing with different system components. We can combine complex tests from blocks which are created by different domain experts, level 3 plus. And create card is an example of such block. Each expert owns a bunch of tests from basic checks to some advanced scenarios. But the amount of blocks with specific logic are usually much less than the amount of different test cases which using such blocks. So, software testing engineer can combine blocks to create test cases. For example, action 1, create new card. Action 2, check card balance using just created card number. Action 3, make a payment. Action 4, run some reports and compare some values. Each action here was implemented by a different person. And another person can combine such actions into a test then combine tests to suits. Here you can see 3 suits combined from existing tests. And this approach leads to more efficient test development in terms of time and money. Software testing engineers gain automation powers using actions with appropriate logic and having no idea what is behind this action. This approach also less error prone because no coding is involved at all at this stage. As our practice shows, any level 1 or level 2 person able to start using such framework in less than a week. And of course, there's still some coding work for some core activities, which can be done by level 3 and higher roles. But it's better to see once than to hear 100 times. My colleague Konstantin prepared a live demo to show how you can do things like that using AWN framework.
Okay, so before we actually start, I want to mention what I'll be actually showing to you today. And I'll show my screen. Tell me if you can see my screen.
Yes.
Okay, perfect. So what I'll be showing to you today is how easy it is to integrate our AWN framework into your CI tool of your choosing, for example, Jenkins, or how it is easy to launch it and therefore integrate it. How easy it is to create a new test and support already existing ones and test suits as well. I'll show you reporting and what functionality we currently have, and I'm also going to be showing a potential for increasing that functionality that we currently do not have. So we're going to start with very simple. We're going to start with a very simple batch file. Now, don't get alarmed. This is pretty simple. Essentially, what this batch file does, it launches our AWN test framework, which is a compiled jar application with 2 arguments. The first argument is a full path to a test suite, which is an XML file, and I'm going to address the structure a little bit later. Bear with me. The second argument is a path to a test folder that contains the tests, which are mentioned in the first argument. Since all tests have their own unique IDs, the suite can reference those IDs, and our test framework will find those tests via IDs in the respective files, since each test is its own individual XML file as well. So this is a very simple setup. Let's launch it and see what happens. Okay, scroll online. Okay. Oh, something went wrong. Give me a second. Something went wrong. So give me just a second. I think it should be. Okay, so if you want to run correctly, which apparently I didn't have set up, that is, I'm sorry, I'm so sorry. I'll show you the reporting what happens if, for example, this was launched correctly. We would see a pass log of this variety. As you can see, it's very detailed. We have essentially the launch of the test, preconditions, some actions happening, tests executing. This log is very detailed, and there's a reason for it. Usually, the test itself is not very complex, and most of the failures during the test happen due to faulty data. So this detailed log essentially allows you to see where they actually occurred during the test, and also essentially just see what went wrong and where the fault data actually appeared. Now, don't worry, this is not our only reporting way to report test runs. We're going to address this a little bit later. Now, let me actually show you the test that this would actually run. And this test is actually an XML file, as I already mentioned. This test only has 3 steps, but as you can see, it has over 100 strings of XML file, and it has a very strict structure. To many QA engineers, this might be akin to rocket science because it's very hard to introduce new people to our framework via those huge XML files with their cryptic structure. And same goes for a suite, for example, that we're going to launch later that only has 2 tests, but it also has its own unique structure. Now, again, for a manual QA engineer, this might be a little complex. Well, for any person, this may be a little complex because those are XML files and they're hard to get through. So we developed our own little solution, which is essentially a web IDE. Now, if you already noticed, I have this web IDE essentially launched on my local machine. You can do the same with a separate Jar application. It is completely separate from our framework, or you can connect to an already existing application that was launched remotely, for example. Now, for demonstration purposes, we'll already have a user configured, but if you need to, you can create different users with different permissions. For purposes, maybe we have one tester that actually creates tests, or we have a project manager that can only view results or what the manual QA actually working on. So let's log in. Okay, so there's a lot to cover from the get-go, and let me address this navigational tab. So since we already prepared a few tasks for demonstration purposes, this navigational tab is actually not empty. And as you can see on this table here, we already have what's called a repository. A repository is essentially a container that can contain multiple collections. And collections are also containers that include tests and test suites, respectively. So we have this kind of hierarchy of containers. Now, the reason why this was done is for ease of exporting and importing. So essentially, this repository and collection later can be exported in its entirety and then imported in a different AWN test editor as a batch. So let's imagine we launch this web IDE fresh. This navigational tab would be completely empty. We'll click on the navigator. This table would be completely empty. What do? We're creating a new repository. Let's give it a new name. Right. And we can also select its type. Now, there's some options for Derby. We're not going to really address that because usually we use a file system. But it is a possibility to essentially use Apache Derby, either embedded, that is embedded in this web IDE, or connect to an already existing instance of it. We're going to use the file system for the ease of access, essentially. Sorry, so let me just type a path. Repository. And this will actually create our new repository in our file system. Hit create and launch. And as you can see here, it actually appeared in our navigational tab. Now we're going to create a new collection. Hit create, and it actually appears in the navigational tab on the left. So as you can see here, the collection already can include tests and suites. Currently, we don't have any because this is a fresh collection. So let's create a new test. Again, it's as simple as clicking one button, new test, create. And this test now appeared in our locked-in navigational tab. Now, as you can probably notice, the test consists out of those three categories: variables, steps, and criteria. If you're a little keen with the eye, you probably notice that this pretty much resembles the structure of an XML file, of a tested XML file that I showed you previously. And it is indeed so. Since our tests are simple XML files, our web IDE can import those XML files and essentially interpret them into those three categories, and also export them as an XML file if we create them in web IDE. So let's discuss each category. The variables are, they're variables. They're essentially like a software program variable, right? Like a programming language variable. They're simply data that can be either predetermined or modified during the runtime of the test that the test actually uses during its execution. It can be something like unique IDs or date, or it can be even a counter for loop. We're going to address it a little bit later. But so far, we don't have a single variable. So let's create one and see how that works. Test path. I'm going to set something up. And I already have, essentially, this is a path to a test we're going to execute within this test. My colleague previously mentioned this possibility of launching tests within a test, and I'm actually going to demonstrate how to set it up. So create a new variable called test path, and it contains the path to our test within our file system. Now go to steps and create steps, a new step. So we're going to call it launch test. We're going to select call test And as an argument, we can actually add a test path. It's gonna be a path to a test we're gonna execute. Now, we don't need to type a const hard-coded in here. We actually have a way to introduce variable values into those little fields with this little structure that actually utilizes built-ins as well, so it can help you find the variable you're looking for. I'm going to hit execute. We also can add input and output variables. Now, essentially what those are, we can essentially pass certain values to the test we're going to call, and also extract the values that the test created. So essentially, this allows us to launch pretty much any test with as many input parameters as we wish to utilize. So let's create, right? And let's actually launch our test and see what happens since we set it up. Let's hit run test within our web IDE. And this is the wrong one. It actually couldn't find our test within the path, which is interesting. I don't know what this happened. It's a little annoying. Oh, I know why, because the path is actually incorrect. So again, we'll go here and we correct our path. I think this is the correct one, and let's launch it again. I'm sorry for so many blunders today. Okay, so the test was actually launched. As you can see here, this is the log of the test itself, and it actually failed because it couldn't find a variable. So yeah, we didn't pass the variable that it was expecting, and this can happen. So as you can see, doing this little reporting system we have within our web IDE, it's very easy to find why our test actually failed, and essentially debug it that way. Now, this reporting functionality within our web IDE is not a full-on reporting solution. We do have different reporting options. We're going to address them a little bit later, but this reporting is mostly for viewing the log of a task and for debugging rather than being a proper reporting solution. Now, the test we're actually about to call actually exists, and it actually in a different repository. I set it up for demonstration purposes. So let's go to the test and have a look at it. Go to test and this test. As you can see here, it only has 3 steps. It simply patches an XML file, then sends well, this is a soft request. Essentially, it sends a request with this XML file as request, and then it runs a little Groovy script that extracts the status from the response of our soft request, and then it runs a little thing called criteria. We didn't address it yet, and that was on purpose because criteria are a big part of our framework. Essentially, what this criteria does, and we're going to click on it, is that it simply grabs a value of the variable that is called response, and then compares it. And this value was extracted via the Groovy script from the response, and then it compares it to a static value of the status, right? So how do I actually utilize this check? Because this criteria is not connected to anything. Well, it's as simple as simply going to the step where the check is actually executed and adding it in the results. We can add a new criteria check. We already have it added. And as you can see here, here's our little check. And we can actually set up a little condition of what it will actually do upon error. So an error, this will mark the test as failed. And it will also show a little custom message in the log saying the status was incorrect. Now, if we launch this test, we're going to see we have different steps. It has its own little category, and we actually extracted the response via our Groovy script, and the check was actually successful because we see the check was actually passed, and therefore our test was marked as successful. Right. So this is very simple. Now let's address the suits real fast. These also have their own specific structure. They have their own variables, as you can see here. We can have a global variable, and it's called stub.uri. Now, if we'll go to this test, for example, back to the test that I just showed you, it also has a variable called stub.uri. But there's a very interesting thing that this variable has a variable type of import, which means that if we launch this test externally via calling this test from another test or calling it from a suit, the variable with the same name will actually be overridden. So if our suit has variable with this value, the task will actually utilize this value instead of the value that it's given in its variables, which is a very nifty little thing for flexibility, essentially. Now, this little suit I actually showed you its XML file, its respective XML file. It only has 2 tests. They'll be executed in the sort as shown here. And it also has its own results tab. If we run it, we'll actually get a result of 2 individual tests, and we can click on each to see the result of each test. Now, this test was successful, everything went right, and this test actually failed, as we can see here with this red color. If we scroll down, we can also see those real red strings where it marked as error, and it says status is incorrect. So as we can see here, our status check wasn't completed within this test. And this happens a lot. So again, this flow reporting solution is very nifty for debugging tests. Now, so far I've been showing you very simple things, essentially how to set up a test, how to use those criteria, etc. But those are kind of like baby's first AWN test. So let me actually show you what a real test looks like that actually was used for testing a payment gateway. It's as simple as clicking import button, click and select, and finding the test1 import in our file system. Click open and click upload. It appears in our navigational tab, and we can click on it and see how many steps there are. As you can see here, we have over 40 steps in this test, and this test is simply a little component of what can be a bigger test, and I'm going to address this later. Essentially, the structure of this test is thus. We're essentially reading data, such as, for example, car data, etc., from a JSON file. Then we configure a transaction. They're all different tool. Send this transaction to a payment gateway, receive a response, check it, and then we collect a number of logs from external systems from middle and back end, and then verify that they all work correct. So I've been talking about criteria. I touched them briefly, and let's see how they're actually utilized in a working test. So, for example, one of the ports we need to configure for our tests, for our transaction, is stan, which is sort of unique ID for our transaction. Now, when we configure a transaction, stan can actually maybe it didn't read, or maybe it's not unique, and we're comparing, and we have a little criteria set up to compare a stan to a static variable of 0. Essentially, we are checking that our stan is not empty. And if it is empty, we're actually going to a different step, as you can see here on the top. It actually calls an action going to a different step, and we actually have and it goes to a step check if type is empty. So essentially, if our stan was not empty, it simply skips the next step and goes to the step after it. So essentially, what this allows us to do is to essentially skip parts of a task that are not necessary, or maybe the opposite. Maybe the check was successful. We need to utilize and run a few more steps to properly set up the test. Now, this functionality also allows us to even create our own little loops, because we don't need to create one condition. We can actually add multiple conditions to this test, and after each step, we can add pretty much as many conditions as we want. So we can, for example, set up another condition that simply makes, that is a counter, for example, right? And we could create our own little internal for loop within our test. So for example, let's say that this whole test is actually part of a bigger test that maybe performs some sort of end-to-end test, right? And this whole 40-step test is actually being called with a single step from a different test, right? And it was unsuccessful. Maybe something would run in the middle end, maybe something run back end. We don't really know, but maybe just in case we want to relaunch this test multiple times. So we can set up this sort of condition to check the response of the test, if it was successful or not. And if it was not, we can go to the step that runs the transaction again as many times as we want. And this allows us to create essentially our own loops within our. And again, as already mentioned, this huge test compared to the demonstration ones that I showed you before, that has 40 steps, can be just one little call away from being one step in a completely different test. Now, this is a kind of its own little conditional approach to how we're designing our tests, and this is a big part of how we even create tests and how we utilize our framework. we have a lot of different actions already set up in our test. I attached some conditions. I touched on steps briefly. Our steps can do multiple things, such as protecting files. They can send REST requests. They can send SQL requests. They can send SSH requests, etc., etc. There are a lot of functionality already included within our framework, but it's not limited to the functionality because we also have plugins, which are essentially compiled jar files with its own strict structure and custom annotations, which are used to pick up those actions during the framework runtime, which my colleague is going to touch on later. And another thing that I still yet to mention is reporting. Now, I already showed you the reporting as a log file. Now we also have our own little HTML solution. For example, the test we ran separately counts as its own seed, and we can look at this run as essentially a seed, right? So this is our own little HTML solution. It generates and utilizes essentially the same log, essentially for the ease of debugging. So we have multiple tests. They'll all be shown in this column. If they have any failed tests, they'll be shown in a separate section. Now, again, this is not the only solution we have. We also have integrated alert reports, report portal reports, testing reports, universal JSON reports, pretty much any reporting system of your liking. Now, again, the one thing I want to take away from this presentation is the configurable, the ability to configure our tests and set up all those crazy conditions to essentially make our tests intelligible while still making them fairly simple within our web IDE. And if you're tired of this web IDE and you want to get a little more advanced, of course, you can always go directly to our test XML files and redact them by hand, and then launch them via our test framework directly without utilizing a web IDE at all. So I know this was a lot of information, so if you have any questions about this demo specifically, I'm ready to answer them. If not, I will pass the word back to my colleague, and he will continue his own presentation.
Okay, actually, we have some questions. The first question is, have you compared AWN with Vividus? What are advantages, disadvantages comparing with this tool?
So I think Alexei Mitenko was actually a little more equipped to answer this. I think the question is about comparing a different sort of interpreter test framework, kind of like Python and Robot. Alexei, would you confirm?
Yes, hello guys. We don't have a deep comparison just now. It's a pretty complex task to compare by different criteria. But short answer is that they are the same. But we have some features that differ from Vividus, and maybe the most important is that our framework is not based on a single Java platform. For example, the first version was developed inside, I can say inside HP UFT, the code of interpreter, because framework is actually interpreter of XML description, was written in VBScript. Presented now, version presented now is based on Java platform. We have also Python version of interpreter, which was requested by our customer. But anyway, all tests could be executed on any platform. Of course, there are some details, but generally, yes. What does it mean? It means that we could use, for example, for UFT, a lot of special plugins which are provided by commercial tools. There are, for example, SAP plugins, plugins for Oracle ERP system, and so on. While you can't develop these plugins from the scratch in simple manner. Python, for example, Python version, it could be used in special cases when a customer uses Python on his in his environment. And the major usage of our framework is end-to-end testing for complex system containing of maybe 10 different systems which are connected with some middleware. So we have maybe Dmitry mentioned somewhere 10th large project where it was used. I guess this is the main difference, maybe. That's all from myself.
Okay, thank you for the answer. The next question, it will be more than one question in one, but let's start. Could you please describe how software quality engineer team members work with the framework? Where tests are stored? Are there any review performed on the developed tests before adding them to the suite?
There are some questions. The first answer, where the tests are stored. As Konstantin demonstrated, tests are just XML files. They are stored inside a version control system like Git. Suites files are also XML files and also stored into Git. In practice, we have, for example, 1,000 test files and, for example, 50 or maybe 100 suite files. Suite files describe combinations of tests, and as Dmitry demonstrated in slide with different card types, suite could, for example, be used to create test data. For example, before regression execution, we should have correct data, tens of business objects with correct attributes. So the suite could be, for example, a combination of a number of tests. So this is the storage is the same as in other frameworks. What about review? This is not about framework. This question is not about framework. This question is about workflow. Of course, you could provide kind of review. You could and should maybe execute test suite before putting it into working copy, into release, say. And this is about your workflow only. But you can deal with these test files and test suite files as with, for example, test files, the same way. That's all.
Thank you very much. The next question is, do you have the possibility to have the test data in JSON instead of XML? Also in the tests, are you able to work with JSON responses and structures instead of XML? What platforms of testing are supported? Desktop, web?
So I can actually answer a few of those. So you mean test data as in the tests themselves? No, the tests themselves are always going to be an XML file, but we do have the possibility of working with JSON files. For example, the test I have on screen right now actually reads and writes into JSON files. We can send a REST requests with JSON files as requests. So we have full-on a REST plugin that we can utilize to send and send requests and receive responses. What was the last question? Can you refresh my memory?
Let me continue, please.
Okay.
There are two versions of this question I could recognize. The first one, could the test structure itself be represented by JSON? Short answer, yes. We have next version where our test structure, say business structure, could be represented in any way in XML, or in JSON, or maybe in Gherkin. The second question Konstantin answered just now. The third version. Do we use this framework with a lot of JSON requests and responses? Yes. Short answer, yes. We have a project with in this project middleware system is tested, and this middleware is based strictly on JSON. There are a lot of technical questions which are due to JSON structure itself. For example, about spaces in JSON and say tags order and so on. But the framework is able to operate with JSON very well. And then what platform of testing are supported? It would be represented on next slides. I believe Dmitry should answer, but short answer is that we could operate with desktop. We could operate with web, and I believe Dmitry will answer.
Yes, actually, I want to add that this framework is data agnostic. So we have a lot of plugins, and if you need some specific data structures or even systems like SAP, it's easily to expand functionality of such framework, adding actions as a plugins. I will show it on my next slide, but Joseph, if you have any more questions, let's answer them first.
Okay, we have currently we have two more questions. The first, actually right now 3. So the first is, sorry, I missed the first 10 minutes. Is this free application?
Yes, free and open source.
Yes, so it's this application is an Epam testing accelerator tool, which means it's open source and free, so you can use it. Just if you need any kind of information or help, just contact with the owners who are the presenters right now, and you can use it on your project. That's true. So the next one, what if I need to send some parameter from one request response to another parameter in request?
Okay, there are multiple ways of doing this. I guess the easiest one I actually utilized in my demonstration tests, where we essentially, let me refresh my memory and go to steps. When we actually send a request, receive the response of this request as a value for a variable. So we can actually write the response to a variable as text, essentially. And then I run a little Groovy script, which essentially extracts the status code from the response. And this is not the only way of doing this, it's just one way of doing this. But essentially, we can save responses into variables and then pretty much do whatever we want with them. Okay, so I think we're done for now. So let's give Dimitri his presentation rights back.
No. We have 2 more questions because the questions are just coming, which is good. So the next question will not be so technical, but let's read it. How many man hours was spent to create the framework, and how many projects use it currently?
This is a simple question and simple answer. Not man hours, but man years. First one, how many projects. We have some, I don't know, maybe 5 projects inside payment practice. The project, this framework was created inside payment practice, and it's basic tool for our testing activities, and it's one of major tools in integration testing CC. So we have, I don't remember, 3 or 4 maybe project, or maybe 2 or 3 project in integration CC. Maybe, but one more detail. As I mentioned already, this approach was created long ago, and his forks are used in a number of projects in Epam. That's short answer.
Thank you for the answer. And the next questions, could you share GitHub link of the project? I believe we can share everything in the follow-up emails, so the presentation materials, the useful links, and the video recording as well. So yes, everything will be shared in the follow-up email. Sorry guys to answer it instead of your name. So, and the next question, is it possible to observe test case?
As it being ran, yes. Actually, if you use after launching manually through our for batch file, even with our framework, you can see the log happening on the screen. And if you launch it through a web ID, the report itself will actually appear as the test is ran. It's just that the tests that was showing you were were going by very fast, and they were essentially finished by the time the reports pop-up window even finished loading. But in the real test case, essentially the report was being written as the test is executed. So yes.
Thank you very much for the answer. Currently, we don't have more questions. So I believe we can continue with the presentation, Dmitry. And if we will have other questions meanwhile, then I can read them.
Yeah. Okay, can you see my screen now?
Yes.
Affirmative.
So we talk about plugins a bit, and here's a slide. Our plugin system is following. If your testing scenario need to communicate with some complex interfaces, you can implement needed actions as plugins. For example, real scenario for SIP testing. We are using LeanFT, which is commercial lib, and AWN plugin as a wrapper around such lib, providing SIP CQI automation possibilities. In a nutshell, plugin is just jar file implementing some interface, which you can use by simply putting it in specified folder inside AWN. After that, every software testing engineer can use actions from such plugin. And we already have a lot of plugins out of the box, but it is easy to add your own to reuse it later on other projects. Here's a short list of our plugins. We have, as you can see, different file operations, network protocols. For some workarounds or shortcuts, you can use Groovy script as a part of test, SQL request with cursor, messaging systems for middleware like IBM MQ, Tibco, Kafka, so on. Also, results reporting is implemented as plugin too. We already have covered some of the most used reporting systems, but if you need to report to some other system, it is easy to implement. We have a universal JSON output with pretty old taste data, checks, validation statuses, variables, and so on, and it can be easily converted to your desired reporting format. Also, for large-scale systems, which are usually dealing with, we have a support of distributed test run. It implemented as a standalone web service component to run the test called test executor service, which use as input test ID, test parameters, and a Git branch. Going to Git to get the test version and the test data for desired system release, and then execute the test using some of available remote host nodes. Or as an alternative, you can provide just test body via HTTP request to execute it. It makes possible to run the test from some external UI. For example, right now we have a project where like a bank clerk can select from a few buttons. Each button creates a contract or card or something like that for its own testing. And in parallel test run, each node can run tests in a separate JVM. 8 logical cores host is able to execute about 8 to 10 tests in parallel on each node. So it's last slide, bottom line. We just scratched the surface to get the idea about AWN framework. And here's some important details to remember. It's action driven. One action could be used in many test cases. We already have a lot of actions like DB request, read file, HTTP request, and so on. But by plugins, you can expand them quickly, fitting for your project needs. Test flow is simple to manage. Suite contains test, test contains steps, steps contains actions. Suite and test can contain shared real-time data, which means this data not existing before the test. And this data can be used by any test within the suite if you need so. Each action type is able to perform some logic, push button, calculate value, SSH session, write file, etc. And all these actions could be combined in one end-to-end automation test, not only web UI interaction or API calls, but covers a lot of other system parts and layers, front, middle layer, backend. And if you lack of some exotic functionality, you can develop custom actions as a plugins using simple interface. You can then reuse these actions on other projects. I hope now you have an idea about what AWN is. That's pretty all from my side. And if you have any more questions or want to try AWN on your project, feel free to contact us. We are here to help. Framework, yes, is open source and available in Epam's Artifactory. So welcome to evaluate it. And thanks for your interest and time. Thank you.
Okay, thank you very much. No more questions were asked in the question tab. So, okay, we have 3 more. Okay, so what type of license used to open source AWN?
Let me answer this. Of license used to open source AWN. AWN is based on a number of libraries which with different licenses. GPL, Apache, MIT, and so on, MIT, and so on. So it's a kind of GPL license. In our practice, we could share a source with customer. That's short answer. We don't have a strict license just now, and it's next step in our development, I believe. We have some questions of this type and working on it. That's all.
Thank you very much. The next question, how the low-level encapsulated framework errors handled, supported if someone finds it?
I'm not sure that I understood exactly low-level encapsulated framework. Could you please clarify?
I think what is meant is if they find a bug in our framework and they're not able to fix it themselves.
Encapsulated framework level encapsulated. Could you please clarify your to the question during test development and execution? So if you mean something about framework defects, so imagine we have running test and framework has some bugs, and they should be handled in any way. If yes, this is a normal Java application, then stack trace and so on. But if you mean, for example, non-trivial system reaction, we have some types of log. Konstantin demonstrated short form of log. We have also a debug log. It's like debugging in, for example, Java development. So the whole web IDE, which we demonstrated, it's a paradigm of, for example, Eclipse IDE, which could emphasize, could help developer to improve his productivity. And the same is here. Debug log, it's detailed description of all actions inside framework, plus actions or events inside test itself. So you can trace all transformation of data and all transformation of all control transformation. I think this question was about it. If you, for example, use this framework and find a defect or could provide new functionality, you could be part of developer team, and then will go by standard development cycle, pull request, approval, merge, and so on. That's all from my side.
Okay, thank you. The next, it's not a question, it just pasted an Artifactory link and it seems it's not working. I don't know if it's a valid link or not.
The link is valid. I think we just have some permissions not set for external users. Yes, I just checked that the link is valid.
Okay, also page of AWN standard actions page, page not found error. Could be the same problem, maybe.
Yes.
Permission issues.
Yes.
Okay, and the next one maybe I missed, but may you show example of test case itself?
Yes, I think my whole demo is pretty much dedicated to showing different ways of interpreting test case, whether it's a separate XML file or its structure in AWN test header, our web IDE. I can show it again, but if you missed my demo, I think it would be easier to look for the recording.
Yeah, exactly. I would like to suggest the same, as the recording will be shared, so it can be checked from the recording.
I guess you can contact Konstantin or Dmitry directly, and they could show different versions of test case after the webinar.
That's fine. It's also sounds like a plan. Thank you very much. No more questions we have at the moment, so I think I can say a big thank you for you guys for the presentation and for everybody else for joining. The usual follow-up will be sent over to everybody in the following days, and hopefully you enjoyed it, and talk to you next time. See you next time in the next webinar, the next upcoming weeks. Thank you very much for everybody.
Okay, thank you.
Thank you for your time. Bye-bye.
Thank you kindly.
Bye bye.